Okay, why don't you stick around, Ed, because we're going to continue on with the panel, and maybe you'll have some thoughts about this. Once again, we're covering 6 topics with the panel, and we're now on topic 3 and 4. So let's serve this up, the getting receptivity. So, question, what's the worst nightmare, worst fear of an owner-manager that would cause them to say, oh, I don't want to do this? And how do you address those concerns? Ed, if you're still here on voice, feel free to jump in on that too. Anybody want to take that?
I think the biggest thing is danger for an employee, and that's where these robots are really starting to change that market. Historically speaking, you put an operator near a robot, and as Ed mentioned earlier, you have to do the risk assessments, but what's the level of injury that can happen to that employee? And with these robots, that's now going out the window. So the biggest thing is just making sure that everybody's aware just how close you can work next to a robot like this, and effectively address those safety concerns.
Ed, do you have a success story? Go ahead. Go ahead. I didn't mean to jump on you. Go ahead, Ed.
I'm sorry. Yeah, I was just going to agree with Jeff right there. That's exactly what I would say is the biggest concern is doing it safely. And what we're starting to see also is a little bit of a trend where instead of going completely cold turkey without any safety, because we've got configurable safety I/O, you can add some lower levels of safety. So instead of putting large 6-foot safety rated cages around it and trying to emulate what a traditional system would look like, we've got customers now adding lower levels of maybe a safety scanner or a light curtain or even a mat and using it as more of a training tool to get the operators comfortable with this type of technology. It's very difficult right out of the gate to get an operator that's seen traditional robots to actually go up and touch one of our robots. So that's a huge challenge. So by adding some lower levels of safety, so to maybe take the robot and slow it down to make it a little more friendlier, and training people, it's really becoming an effective way of implementing this technology. And now after 6 months or 8 months, we're starting to see those lower levels of safety being removed because the comfort levels are coming up.
Ed, I got another question for you. Do you have a success story like the absolute black-white success story where the client was absolutely resistant and overcame the resistance because? What's your biggest success story?
Well, yeah, if you look at maybe an application that we had down in the Florida territory, we had a customer that could not get past just the ROI on it. So when you look at our product and you think about it like you would implement traditional robots, where we really separate ourselves is after you actually buy the robot. So dollar for dollar, it's I would say we're right in line with a lot of the traditional robots from a load standpoint. But where we separate ourselves from everybody else out there is how quick and easy and cost effectively can you deploy the robot. So by not having a system integrator, the high level guy involved where you actually have to write a check for somebody to do something is a huge savings. By not having to put safety cages around it is a huge savings. So I'd say one of the bigger success stories that we've had and the bigger impacts was an account down in Florida where a guy just couldn't get past that, and his plant manager got him to actually just go ahead and try one, and just seeing how quickly for himself that robot was able to be implemented and deployed and making money for him was really a pretty amazing feat. And we got a phone call the next week from that CEO saying, I was completely wrong. I'm really impressed, and we're ready to deploy more of these things. So
great.
It's a pretty pleasant phone call.
Actually, Ed, you raise a point that helps us transition to the next question, which is programming and day-to-day management. You mentioned a few seconds ago that these collaborative robots don't require a systems integrator. Well, just to the right of you on the screen, your left, our right, is Jeff Schreiber, who's from Bastion Robotic Systems Integrator. And so, Jeff, your whole business model is turned upside down as compared with traditional robots where they absolutely need somebody like you. And now the client doesn't. So what does that do to your business, and are you able to adapt, and how are you adapting?
It's definitely been a shift over the past year or so. The biggest thing for us is that where we're maybe not getting involved on the programming as much with the collaborative robots due to the way they can be taught just by releasing a brake and moving them into place, we're able to come in and work with the end users on end effectors. We've got a lot of standard end effectors that we sell. We also design to customer needs, and we can adapt any of our solutions onto these collaborative robots as well. Beyond that, what collaborative robots are doing for us is possibly getting us into businesses where on the small and medium-sized factories, they weren't as open to robots originally. So now they've gotten a $20,000, $100,000 robot on the floor, and they're increasing production. Well, now their manpower on the end of line can't keep up with palletizing parts or placing parts into bins. And that's where we can now come in, thanks to guys like Ed getting in there and working with the customers on the safety side of things. We can move the step beyond that and help to move the large traditional industrial robots on for producing the goods onto a pallet to go out the door on the trucks.
So let's come back to Charlie. Thanks very much, Jeff. I'm sorry, but back to Charlie on the investment tax credit and all the stuff that you can apply. The stuff we're talking about now, getting ready to get ready, you can track those hours and get a tax credit, right?
That's correct, and that's the R&D tax credit. And for a second, I wanted to go back to the point Jeff was making, and it also came out in Ed's slide. A lot of the companies that are purchasing this equipment, one of our major clients that bought both Baxter's and Universal's is in the injection molding business, and most of their competitors left this country years ago. So by buying this equipment, they became cost effective, they can stay in this country, they've expanded, and then when they expand, they do have more complex processes, then they can go back and see Jeff and buy the more complex equipment. So, I mean, the whole reshoring and the reemergence of U.S. manufacturing is important here. But to answer your question, it's going to be all of that internal labor, analyzing the purchase decision, all of the, even the direct labor and setting the facility up again once you bring in the robot, and it is going to be the integrator when you have the more complex equipment. And back to one other question you asked about resistance. Always with new technologies, there's only a finite amount of companies that are willing to be early adapters. I think what's great about what you see here is you can see the videos, you can see the volumes increasing. If you go on Bastian's website, they've got excellent detailed case studies. They're only one page each. They're all in different industries, and you can look and see what other companies in your industry have accomplished.
Great. Okay, well, Ed, thanks so much. We got to move on to the next piece of things. And panel, why don't you stick around? But for the moment, we're going to switch to our sponsor. We are, at the top of the show, we explained that we're sponsored by NIST, National Institute for Standards and Technology, and our regional partner is OMEP, and we spoke earlier today with their sales manager. So, Andy, roll that tape. Heather, are you there?
I'm here.
Good. Okay, I have several questions for you, but let's begin with what is OMEP's mission?
Our job is to help manufacturers with process improvements and innovations so that they can be more profitable.
Okay, great. And now, who are you guys?
We are a program that was designed by the Department of Commerce to support manufacturing in each state. There's 80 MEPs, Manufacturing Extension Partnerships, and we are the one that supports Oregon.
And so, are you doing this all by yourself?
On this particular event, Impact Washington, the Washington MEP is helping us out, as well as Tech Help, which is Idaho's MEP.
Okay, so it makes perfect sense that OMEP would sponsor an innovation showcase about innovative robotics that make workflow faster. Is sponsoring this kind of event your major activity?
We are primarily a consulting firm.
Okay, what kind?
We specialize in process improvement, production throughput, reduced breakage, strategic help on the business side, supply chain optimization, and new market development.
Okay, so you're a program of the Department of Commerce. Does that mean that there are subsidies or attractive pricing, or how does that work?
There are subsidies, both federal and by the state, but we also work strategically to bring in those types of grant programs that would be applicable to our customers.
And how many consultants do you have?
We currently have 15.
Okay, 15 just at OMEP. And what kind of consultants?
They're all over the map. We have mechanical engineers, chemical engineers, ex-CEOs, business managers. We run the gamut.
You know, if you're a small business owner, there's a lot to do. You run out of daylight and you just don't have time, or you don't think you have time to get a consultant up and running and smart enough to actually help you. So do you have like a really cool success story where it's a sort of a resistant customer and a big opportunity to make improvement that was seen by your consultant on the first visit, and then really cool results? Anything like that?
I do. We work with a company called Cab Door out of Salem, Oregon, and they are a custom kitchen cabinet door company. And when we started to work with them, they had a process that was taking them two and a half days to produce one full kitchen of cabinet doors. By the time we were finished working with them, it was down to a 5-hour process.
So then the math on that is 80% improvement in throughput.
Yes.
And is that a typical result?
We see those results a lot.
Well, let's see what the client himself has to say.
The beauty of working with OMEP was they came in and taught us how to see our operation in ways we'd never seen it before. OMEP has given us that competitive advantage. So we have all this capacity, we know what our costs are, we've improved our fall-off rates, and we're able to go down and bring pricing and services to that market that they haven't seen before.
Heather, this must be fun for you and for the clients.
It is.
Okay, thanks a lot, Heather.
Thanks, Skip.
Okay, so gentlemen, you are both consultants, right? And how would that work for a local MEP consultant to be talking to a client before the client talks to you? I mean, so there are lots and lots of folks on this call today looking at robots. Would you rather have them call you directly, or does it work to have them work with a local MEP consultant from your point of view?
Well, both things work. I mean, we work closely with ITAC, which is the New York City area MEP consultant, and I think some of the points Heather made. First of all, their core mission is to help manufacturers, and they have a broad range of programs, and they've been serving these clients and have a trusted relationship with them for, in some cases, decades. So you can really benefit from their relationship. And as Heather said, they have cash grants, they have training cash grants. They do a lot of lean manufacturing processes, so they're a very valued partner.
Great. Okay, Jeff, any thoughts from your point of view as an integrator?
Sure. From our side, we absolutely love when the MEPs can go in and help. We will certainly take the direct sales call, but the advantage when they go in first is that the leads are qualified. They're able to walk through the plant floor with the customer. They're able to get some of the basic questions answered. So what products are we handling? What are we going to be doing with them? Additionally, they'll be able to steer the customer, I guess. So there may be applications where it's not feasible to put a robot in. The task may be changing, and that's a lot of concern that we run into a lot of times. These guys will have the expertise to know kind of what applications are being addressed. Okay, great. And if you're not aware of the MEP program, or you want to know how to find a MEP, just go to the browser, type in NIST.gov, and then type in on the search MEP, and you'll find them really, really easily. So, okay, I think it's time for a time check. It says here we should be starting SEEGRID just about now. I think we're almost nearly right on time. So if we can have Mitchell Weiss join us now from SEEGRID. Do we say the SEEGRID, or do we say SEEGRID or SEGRID? How do we say that, Mitchell?
SEEGRID. One word.
SEEGRID, as in seeing a grid, eh?
Grid.
Okay. I'm not going to ask you to ask questions about the Ed Mullen discussion, but I do want to ask Jeff and Charlie if you have any questions for Mitchell, or things that you want to make sure he pays special attention to.
Yeah, I mean, go ahead, Joe.
As a systems integrator, we come across AGVs on a plant floor, requests for AGVs pretty regularly. Traditionally speaking, they were costly to implement and therefore left out of a lot of our solutions due to having to cut wires into the floor, adding GPS-type systems to control the AGV routing. And additionally, beyond that, then let's say something changes on the plant floor, you had to bring engineers in to reprogram the AGV system, essentially. How is SEEGRID reducing that upfront cost now and then increasing safety overall?
Oh, what a great straight man. The trend that we're going to see here in this session today between me and the other suppliers is it's about easy to use, easy to deploy, easy to configure, short run possibilities, all those kinds of things. The way that we program SEEGRID vehicles, and when we talk about what it is we do, we'll be telling you we make vehicles, is what we call walk through then work. It's basically the same as lead through then work on a robot. You drive the vehicle along the route you want it to follow, and you are done. And then you follow that route. I think the biggest hurdle we see in terms of the customer deploying it is they have to rationalize their workflow first. Whether they use a traditional robot, a collaborative robot, a walk-through and work vehicle, a lead-through and teach robot. If they don't know what the process steps are, they experiment with the robot, they waste a lot of time and money. If they've got their process steps figured out, then like the Universal Robot and like Baxter will see, the SEEGRID vehicles are easier than programming a VCR.
Oh, that's very, very easy. Okay, Charlie, you had a question?
Yeah, Mitchell, since you have a mobile device there, I was just curious, is there an ideal plant size where once you hit that threshold, the odds are the payback's even better in terms of square footage?
Yeah. When we're looking at, there are a couple of things that make the payback a no-brainer. If you're running 2 shifts and you can keep the vehicle utilized, the cost of a forklift driver is pushing anywhere from $35,000 to $50,000 a year. So it gets pretty easy to get a payback pretty quickly on that kind of stuff. But typically, if the facility's under 100,000 square feet, probably don't have a great fit because you don't have a lot of long runs. The time that people are acquiring the load, dropping the load, making decisions around the load, we don't take that time out. We take the time out that they're just traveling horizontally.
And then the only other add-on, and I think you may be covering this, I'm under the impression that your product may be helpful on workers' compensation costs, back injuries, those kinds of things.
Yeah, I do cover a little of this, but the biggest cost, well, the number one injury producing thing in factories and distribution are manually driven forklifts. Over half the fatalities are based on those alone. And where it's not a fatality, it's just people working with pallet trucks and tuggers stepping on and off. The number one workers' comp claim there is ankle and knee injuries. When they step off, they stumble, they fall, they hurt themselves. In the distribution market, workers' comp claims for throwing cases and driving trucks and getting on and off them is about $7 billion a year in the U.S.
Okay, great. Let's move right on in. And Mitchell, why don't you take over and show us your stuff? Before we do that, one more quick safety tip on PC speakers. If you got your PC speaker on, please turn it off. Okay, here we go.
All right. So I'm going to talk today about material handling technology, a little different than what we've seen up till now. Gee, my screen just went away. All right. There it is. Okay, we're going to talk about this material handling stuff. The next slide, Joel. So what SEEGRID vehicles do differently is our guided vehicles And we call them vision-guided vehicles now. We used to call them vision-guided robots or mobile industrial robots, but we had some customers beat us up about that because their safety rules around robots are different than their safety rules around vehicles. Okay, fine. Our vehicles use cameras as a navigation tool. So just like you walk around a facility and identify things in the facility and navigate doing it that way, that's how our vehicles work. The advantage of this is that you can work in any unmodified environment. So there's no tape, there's no wires, there's no laser targets to put up, there's no barcode labels to stick on the floor, magnetic tape cutting the floor. The installation cost goes way down. But the other advantage you get out of that is the flexibility goes way up. You can now start using these in applications that are more dynamic. Using these cameras, and there are other ways to do landmark-based navigation, which isn't quite what we do, but close. Using these cameras, we capture lots of data, and I'm going to show you some pictures of that. But this answers the question that some of you should ask, which is how reliable is this? How can it manage a dynamic environment where the materials I'm moving around my warehouse are changing all the time? Well, you'll see the data. We collect so much information from the environment that just like you as a human being, our machines can adapt to that because when some things are changing in the environment, a lot of other things aren't. So it's a very robust system. And then this concept we call walk through then work really simplifies the operation. So a SEEGRID vehicle is a vehicle that can see where it's going. The base vehicle is a standard industrial truck. So traditionally, AGVs use special purpose trucks. We actually buy ours from one of the big truck manufacturers, and then we retrofit it with our camera system. And what you see in the top right is the camera view. There's 5 stereo cameras on every truck, and you're seeing 3 fisheye views. One of them is looking up at the ceiling and 2 off to the side and to the front. The bigger picture with the 5X on it are some of the interest points that the system captures as it's building its 3D model and localizing itself. But it's doing that looking all around the truck, 360 degrees around and on top. And there's 5 of those cameras, so we're actually capturing about 1,000 to 2,000 points of interest on every snapshot. There's a thing on the left called the GUI, or the Graphical Operator Interface, and that's part of what makes it easy to use. We heard Ed talk about that with the UR. We have the same kind of idea. A person on the factory floor who drives a truck is the same person who programs this truck. They tell it they're teaching a route by punching a couple of numbers in on the screen. They drive along the route. They tell it they're finished. They take it back to the beginning of the route, and they can run the robot. So there's no outside computers. There's no communicating over Wi-Fi or some other RF thing. There's no central controller with a map. It's as simple as driving it and running it. And then at the bottom, you see that little yellow can that says safety. That's your Performance Level D certified laser scanner safety device. These trucks pull 10,000 pounds, and they do it at 4 or 5 miles an hour. So they're collaborative robots in the sense that they're made to work around people. And you'll see some of that in the videos. In distribution centers, we're dodging forklifts, so to speak, all the time. To do that safely when you're pulling 10,000 pounds, we build a safety cocoon around the truck. So that safety cocoon is essentially imagine a force field around it, like around the Starship Enterprise. If anything breaks through that force field, we stop the truck immediately. And there are OSHA standards on this, ANSI standards, and ISO standards on how quickly the vehicles stop, whether they can touch you or not, how much force they can apply, how much clearance, etc. Someone's asking what the footprint. That vehicle you're looking at right now is about 1 meter wide and 4 or 5 feet long. It's a traditional stand-on truck. So how they're used, a little repetitive, but you see to the left of this picture, there's a person driving the truck along a route. The cameras are taking pictures all over, top and bottom. and around and around. Our trucks don't automatically grab their payloads. Again, the handling of the load, the pallets or whatever you're handling varies. It's not in the right position. So an operator takes the truck, forks the load, sends the truck on its way by pushing a button, and then the truck's doing its own thing. And we have a couple of different styles of trucks. We have pallet jacks and tuggers, and we're working on lift trucks. So there's a whole flavor of them. So that's just an intro on what a vision-guided vehicle is. And now I'm going to talk about what the benefits of material handling are automatically, and what if you could do them, and what's different about what we're doing and has been done before. So the questions you have to ask yourself, and this is sort of lines you up for what are the right applications, is do you move materials repetitively? So a manufacturing operation, this is a pretty easy thing to figure out. At the end of the line, you're taking things from the end of the line out to the loading dock. You're bringing things from the dock to the shop floor. You're bringing things from sub-assembly areas to assembly areas. That goes on pretty often. The other place that stuff happens a lot, in fact, much more, is in distribution centers, whether it's food or retail or clothing. Material goods come in, they go into storage, they get picked, orders get put together, and they get sent out the door. The difficulty with automating that, and why it's been almost ignored by industry for the last 20, 30 years, is it's very seasonal, it's very dynamic. You're not moving cases and cases of pumpkin pie mix in July. You move pumpkin pie mix in November just before Thanksgiving. So the routes are always changing. The amount of material you're moving from A to B is always changing. And so you need a system that doesn't require infrastructure. So you have a repetitive situation, which is good for automation. And in this case, you have a repetitive but dynamic situation. Labor costs, as I said, and I'll say some more, the most expensive part of a forklift truck is the guy driving the truck. So there's pretty much a one-to-one savings here in their time. Now, what we don't typically do is replace a forklift driver with a tugger or a pallet jack. What we do is we make that driver much more effective. Forklift trucks are meant to lift things to height and to select and sort things out, but they actually spend 60 or 70% of their time just moving horizontally. So it's a real waste of the truck. Safety, we're going to talk about that. But if workplace safety is an issue, then this is a good solution. Productivity, throughput, predictability is one of my favorites. One of the things that kills manufacturing and distribution is variability. And we all know this at the beginning of a shift, at the end of a shift, when someone has to go to the bathroom, at lunchtime, at whatever, your flow rates change. The nice thing about automated machines is they run at a constant rate. So you can now size your facility properly. You don't have to design for the peaks of the pre-break rush or something. You just go on. Those are all kinds of things that can happen. Basically, for material handling, you have three options. You can stick to what you're doing and have people driving your trucks. And according to the material handling industry, that's about $47,000 a year. Some places it's less, some places it's more. If you're running 3 shifts a day, that's $140,000. Your traditional choice up to now has been automated guided vehicle systems. And automated guided vehicle systems traditionally follow a wire or tape on the floor. Sometimes there's magnets drilled in the floor. Sometimes there's targets put up around the facility and lasers that scan it. But in all cases, they require somebody to design the truck for you, bring the truck into your facility, install the guide path, they call it, program the system computer that handles the traffic management, and then deploy the system. With vision-guided vehicles, we're using standard vehicles. Standard trucks is the chassis. So if you're already running forklifts and pallet jacks and tuggers, you have the batteries, you have the chargers, you have the equipment you need, you have the people who are trained and licensed to run the equipment. There's no additional cost there. And you don't have to do any of this infrastructure deployment. So we're looking at our typical deployment time for a customer to put in a fully automated system that includes 5 or 10 vehicles, say, is usually about a week. One of the things to look at in the cost of manual labor, besides just the labor cost, are all these other costs that you see in your facility: the cost of variability, inconsistency, shortages, failures, injury costs. As I said, in grocery distribution, workers' comp costs are about equal to the annual labor costs in the U.S. Delays are a biggie. If you're running a manufacturing operation, you're running an expensive process tool, and there's nobody there to unload the tool, the tool shuts down. And that's much more expensive than the cost of the vehicle or the robot or anything else you're going to use. Another thing that we see a lot in the distribution space, it's a very seasonal business. Christmas is obviously the big time. You just can't get enough human beings into the building that quickly. So there's a whole hiring cost of bringing people on. And one of the other interesting things I've seen a lot is when Company A moves into the same industrial park that Company B is in, they offer the people 25 cents more an hour, and everyone leaves one company and goes to work for the other. So the machines don't do that. Here's some of the bigger drivers that we've seen spurred our customers on. There were questions before about what are the barriers, what are the holdbacks to doing this stuff. So safety is obviously a biggie. And on this slide, I've got some of the safety statistics. Those are just in the U.S., by the way. That's not global. The labor costs we've talked about, throughput we've talked about. We see a lot of customers with lean initiatives in place. You want to cut your inventory costs on the floor. You can only do that if you know the delivery rates and times, and you can control those. The ergonomics issues of what people can lift, what they can carry, what they can push. A lot of applications out there are people pushing carts around, and a lot of the ergonomists are coming down on that. So we use tuggers to pull those carts. And then Skip was talking a little earlier before about energy efficiency and those kinds of things. Well, one of the things that we do, and if you've ever seen a person driving a forklift truck, you know what happens. We don't accelerate like a rabbit at the beginning of the dog race. We accelerate smoothly and slowly. So the life of the equipment goes up because it doesn't wear down as much, and the energy use on our battery-powered trucks is improved. And just to make you feel like you might be being left out of the rush, we've collected a bunch of quotes and statistics from people. I have the sources available, and they're too tiny to see on the screen, so you'll get those when you get handouts. But by 2025, this is the former head of the Robotics Industry Association or Association of Automation or whatever. By 2025, they expect 50% of industrial truck sales to be automated trucks. You should know that 1 million trucks sell a year worldwide. 74% of manufacturers surveyed are looking at automation. HEV sales in the U.S. in the last year have gone up 30-40%. Warehouses plan to use more technology. You've seen the injury costs, 97,600, 100,000 accidents a year. And the cost of running a truck, owning and operating a truck, the cost of the truck is only about 4 or 5% of that cost. 95% of that is the person driving the truck. So looking at different technologies, vision-guided vehicles versus manually operated powered industrial trucks versus manual trucks, the kind you pull and push around yourself, versus conveyor systems that do sorting and handling, or making investments in fixed facility-based stuff like HEVs or ASRSs. Now, this is becoming the trend of this talk, right? It's easier to train and deploy vision-guided vehicle than it is something that has to be physically installed. It costs less to run it per hour than something you have to maintain or a manually driven truck. It's a flexible system because you can reteach it on your own. The cost of maintenance of our products is pretty good because they're based on standard truck chassis. So the spare tires and batteries and gearboxes and motors, they're commercially available. It's nothing I can get a nice 200% markup on. Cost of scaling the system, we're going to talk about that a little bit. You can put in one, then you can put in another one, then you can put in another one. Because there isn't a centralized infrastructure that drives these things, there's no burden cost that you start with. We sell our trucks for between $75,000 and $90,000 depending on the model of truck. And if you buy one truck or you buy 10 trucks, it's the same per truck cost. So it's easy to deploy them one at a time, two at a time, five at a time, whatever rate you can uptake them into your facility is. And you don't have to spend a bunch of money up front on capital equipment, or as one of my customers calls them, monuments, before you can start putting the things in. So before we start the video, and Andy, I'll pump you in to start it, this is to show you how the technology is working. In the upper left, you're going to see a vehicle traveling through a facility, and it happens to be in Europe. On the bottom, you're going to see those three camera views, which are kind of fisheye distorted images that 3 of the 5 cameras have of the facility. And you're going to see to the right front of the vehicle as it's moving, to the left front, and up above to the ceiling. And on the upper right of this picture, you're seeing just one of the stereo cameras and all of the little features it's identifying off in the distance. And some of the things you're going to notice is what look like plain white walls to you and clean floors to you, to the vision-guided vehicle look like a lot of detailed issues, because they are. So spots of dirt on the floor, lights on the ceiling, wrinkles in the walls, all those things are useful for navigating. So think of a sailor out in the middle of the ocean, all the stars he can see, and how well he knows where he is. It's the same kind of thing with this technology. Okay, go ahead and run the video, please. There is no sound with this. I can grab a pointer. So here you see these little dots are features it's finding in the facility. And as it's driving through the facility, it's taking each of those dots that it finds, and it's storing them and using each finding of them to reinforce its belief in its model. In this image here, keep it running, you can see this white wall that the vehicle is going by. Well, there's those pallets that are there. And you see how many features it gets out of that. This looks like a blank white wall to you and me. It looks like a lot of stuff to this machine. And we're going to run this one time because there's something neat I want to show you. If you look down here, you can see this 360 view that the system is seeing all around itself. Right here, you saw a forklift go whizzing by. That doesn't become part of the model because it came in and out of the picture so quickly. And when the vehicle is following in that model that it's built, it's only going to be looking for things that were stationary. Okay, good enough. Next slide. Click. Let's talk about some of the things we've done with this stuff. There's a whole slew of applications that we do it with, or do with it. And I wanted to stick them all in one slide, so it's kind of hard to see. But the typical things are a thing we call parts to line. So in manufacturing operations, running the milk runs of the parts to the floor. Typically, there's somebody driving a tugger or a lift truck, and he's running an 8-hour shift, driving dozens of miles a day, pretty bored out of his mind. Tends to bump into things. If you ever walk into a facility, you'll always see the ballers are scratched, the side of the pallet trucks are scratched, the side of the tuggers are scratched, all that kind of stuff. So we do a lot of parts to line. That's our biggest application that we have out there. Finished goods to the end of the line, that kind of thing. And in distribution, the big application for us right now is a simple thing called put away. If you have a distribution facility that's 100 or 200,000 or even 1,000,000 square feet, you might have 50 or 100 aisles in the racking that are a couple of 100 feet long, and somebody is driving a lift truck from the loading dock where the goods are coming in down to the end of one of those aisles and then raising the load and putting it on the rack. What our system does is take the load from the loading dock, deliver it into a spot in the aisle near the rack where it has to be put up, and a water spider, a person driving around on a lift truck, has a job of putting things away. So they're spending 100% of their time doing load acquisition, placement, lifting, and lowering, and the pallet trucks are doing all the horizontal movement. The typical way that our customers end up looking at that, and one customer that's run the numbers very carefully, is every time they put a pallet down, they save $1.50 just in the travel time. So that's a pretty good deal. I want to show you one case study, and then I'm going to shut up. One of our customers, and we have a bunch of these videos on our website, so hit the website if you want to see them, is a packaging company that makes the plastic and foil packaging that go on juice boxes and all those kinds of products. And as we know, that business is growing, so they grew their plant, and they had to expand the facility, and they had to move these large paper rolls from point A to point B, or film rolls from A to B, take the trash out, do all kinds of things over longer distances. They had a couple of issues they were facing. You're going to hear them talk about it in their video. One was they had safety issues with people doing it with trucks. The other was it just wasn't very cost effective to have people running these long distances. And an interesting thing was when they had to plan the new facility expansion, by putting in this automated material handling, they didn't have to rearrange where all the equipment was to make sure they always had the shortest path to deliver stuff because the cost of delivery was so low. So now it became easier and less capital intensive for them to build their add-on facility, connect it with a tunnel, and put in this piece of automation that did the moving for them. So if you want to roll that tape.
Packaging, located in Story City, Iowa, operates 3 SEEGRID robotic industrial trucks in their manufacturing plant. The GT8 double-length pallet trucks transport raw materials from the dock to the presses. The GT10 tow tractor provides a unique way of combining efficiency with safety. American Packaging puts the GT10 to work by having the robot transport heavy materials needed for production to the machines in a timely manner while taking the operator away from any potential hazards. Torrance Incorporated of Des Moines, a SEEGRID distributor partner, recommend that American Packaging add the GT10 tow tractor to the robotic fleet when they discovered one robot could do the work of 2 associates.
Working with American Packaging is kind of a breath of fresh air because they see a vision, they see something that's going to improve their product, that's going to improve their bottom line, and the whole time they're thinking about their customer as well. So the combination between Torrance and SEEGRID and partnering with American Packaging has been fantastic.
The challenges that we face here in Story City, we've seen a 33% growth over the last few years as far as sales. And with the growth in sales, of course, means increase in materials needing to be shipped in and moved to the presses. My biggest challenge was trying to get this material to the machines so we could print on them without having to add any additional labor costs. We chose to use the robotic industrial trucks over manned equipment, basically to take the human element out of moving material. Anytime that you can automate a process or engineer out specific safety issues, we try to do that. With the robotics, we're taking basically the human element out of moving material from point A to point B.
And the last slide he said, pushing the last slide through, is the way we suggest people get started. And I think working with the MEPs is a great idea, and we have provided some information for them to help. But we have people who understand how this stuff works, whether they're dealers or direct personnel. And if our potential users think they have an application, meaning they move stuff from A to B and they'd like to do it more cheaply, then we help them look at that, figure out what the most effective way to use the equipment is. Typically, if our customers come to us and say, I want a model XYZ and I want it to do these things, they're probably not right. If they come to us and say, we have a problem moving stuff, can you help us figure out how to move it more efficiently, then we can help them a lot with the stuff we have. So that's the scoop. Yep.
Okay, well, thanks so much. And let's ask our panelists to come back in. And while we're waiting for them to show up, you did have a chat question. It's about footprint. Now, I know you addressed footprint, but is there the actual dimensions of the tug and then maybe a footprint around it that it needs to operate within?
So there is the dimension of the vehicle and the load. And from the safety standard perspective, you have to have a clearance of 0.5 meter on each side of the widest part of the vehicle or the load. If it's not 0.5 meter, you can still operate the thing, but you have to indicate that as a hazard zone. So basically, the room we need, and we can tailor the safety fields and things a little bit, the room we need is the width of the load plus a few inches for variation in travel, and you have to look at the space you need to turn the vehicles around.
Great. Okay, Jeff, Charlie, any questions?
Yes. First of all, that was a great presentation. And what I wanted to ask you, quite familiar, I guess like a lot of people, with what I call old line forklifts, and there are dealers for those guys everywhere. But you were talking more about automation, customizing it. Customer may not even know which unit to buy. So I guess my question is, where do our clients get one, and how does distribution work?
Okay, so SEEGRID sells product directly, and we have dealers. Some of our dealers are actually Yale Heister dealers, and some are Nissan dealers, and Bastion is one of our partners, actually, and have sold some of our vehicles. We also are OEMing the technology currently to Raymond. So Raymond Corp has an automated pallet truck and tugger that they make that look like the ones that SEEGRID makes. We don't care who makes them. And Yale Heister has announced that they're working with us, but they haven't introduced the product yet to the market. They have demoed it at MODA. So there's plenty of places, but the easiest place to start is call us up, dial 1-877-SEEGRID. We'll set you up with a dealer in your area if there is one. I will call on you direct, or whatever the case may be.
Thanks, Mitch.
Jeff, you got anything?
No, I think Mitchell's presentation was excellent.
Great, great, great. Well, let's move on to the next actual panel topics. And again, we're taking it in thirds, and we're going to do topic 5 and 6 right now. And Mitchell, why don't you stick around for this, because you might have some insights on it. But the big question is, the uptick on deployment of these robots, the collaborative robots, is really quite substantial just in the last 24 months. So what congealed, or what confluence of forces happened to make this happen all at once like this?
Well, we like to think it didn't happen that fast. I think you have that lovely picture of the Stanford robot.
Yeah, we do have that lovely picture. What is this thing?
Well, the SEEGRID technology is based on the PhD thesis of a fellow named Hans Moravec, who's one of our founders. And that thing you see, the Stanford cart, was his PhD thesis. That is the world's first vision-guided mobile robot. And that vehicle had one camera on it that was mounted on a rail, so it could move from point A to point B to get the stereo view, because cameras were too expensive to put two on. And it took 24 hours for that vehicle to navigate its way across one room. So when Hans was working on that, he started looking at the growth of computing power and the cost. And around 2000, 2001, we got enough computing power, we could make the cameras cheap enough, we could use low enough power that we could mount it on a truck and sell it at a reasonable price.
So
and
beyond
the same thing with all the other robots.
So beyond processing power in Moore's law, what was the biggest impediment or the biggest obstacle that you had to overcome to make these things actually work?
Well, Moore's law and processing power is a pretty big obstacle.
Well, yeah, but Intel was taking care of that for you. So in your shop.
In our shop, a big part of it was the imager technology. CMOS cameras became ubiquitous in cell phones. Actually, the cameras we use were the ones that are used for blind spot detection in automobiles. So when the stuff started to hit the consumer commercial markets is when the cost of those things. I think everybody who's in the robot industry knows and remembers, I certainly do, when a single monocular camera to work with a robot was a $50,000 event. Well, the chips cost me a couple of bucks. So we continue to develop the software, and thankfully the hardware guys continue to develop the hardware. B9 isn't here to tell me about the time check. He'll show up shortly, but we're running short of time. I just want to do one more question in this segment, and that is, let me ask the iPhone question. I wonder whether I should buy an iPhone 6 right now. Should I wait for the iPhone 8? It's going to be so much better. What's coming next on these things? 2 years from now, what's the whole collaborative robot industry going to look like? And should I wait, or is it worth it to buy now? I wouldn't wait. Well, the point is, we've talked about this, the payback on these things is pretty good. They do great stuff. 2 years from now, they'll do greater stuff for less money. They actually won't do it for less money. They'll do more for the same amount of money, because we all like to make money, right? If this was something that took a 5-year payback, I would say don't do it, because in 2 years it's going to be obsolete. But where we're talking about machines here in this whole, from beginning to end of this thing, where we're talking about 1 year paybacks, why are you going to wait 2 or 3 years for the next generation product?